Hello again, Kevin Cull, PM Head of Cloud Management Solutions here at Supermicro, continuing the podcast on sustainability. In the previous video, we talked about lifecycle management of the Schneider Electric PDU. In previous videos, there was discussion about cascading PDUs for Schneider Electric. Today, we're going to talk about the PX3 Raritan controller or PDU. It brings in quite a bit of innovation in regards to sensor data collection. You'll see that in what we're going to expose within our descriptors of specifically SCC for the PDU. I also want to mention here that some of the PDU descriptors are still in development and are under modification. We'll actually finalize and complete that in the 3.11 release, which should be available by the end of the month. So let's dig into this PX3 and see what innovative sensor data is being collected and what we expose. And let's do it. So the first thing is we're going to log in to the landing page here of SuperCloud Composer. We're going to sign in as admin. Global admin again is local access. You can certainly log into SCC from a Active Directory service. We talked about this in previous video clips. I would encourage you to look at quite a bit of different use cases that SCC brings to the table in managing your complete data center. Everything from liquid cooled to PDU management to compute management, server lifecycle management, top of rack switch, and so on and so forth. So let's log into the sandbox here and observe what we have in the PX3 controller PDU. And let's make sure I put in our password here correctly. All right. So this sandbox is actually across the Pacific here in Taiwan. So we're going to see a little bit of sluggish performance here, but hopefully it doesn't impact our demo here and what we're trying to show you here in regards to the PX3 Raritan PDU. All right, so we're going to navigate into what we call the PDU console. And the PDU console is where we provide that lifecycle management for PDU. You can see here in our PDU list, we have quite a few PDUs that are being developed and tested and validated in our sandbox here. But we're going to look exclusively at the PX3. And so again, this is the PX3 5872V-V2, and it is a Raritan PX3 that is manufactured by Legrand, is the manufacturer of that. And they're doing some exciting things in PDU management and control. And I'm very excited to dig into this and show you what they have offered here in their PDU. So in this particular screen, we give you sort of an overview of various different collection or metadata that we've extracted from the PDU. Things like the product SKU, the number of outlets, a firmware version, serial number, things that are important that you get an idea of what PDU that you're performing that lifecycle management. And then you can also see here in the top here, we have a scrolling carousel view that basically provides some high level type of metadata that is being extracted from the PDU controller itself. You can click over here onto the BMC of that PDU by logging in there and looking at various different things. Why would you do that? Maybe you have the need to do that as far as making some changes there in regards to the PDU, such as IP address and so on and so forth. So again, we're in a read-only mode, so we're extracting that data from the PDU, and we're not making any changes as far as IP address or management of that PDU. It's important that you connect over to that and make those changes. The only changes we're going to be actually making are manipulating the outlets of turning it off and on and rebooting, and then also making changes to threshold settings associated with the PDU. But everything else from a management perspective is performed on the PDU itself. And then also we have PDU detail here that we are exposing to as well. This is a little bit more information to showing you things like the number of overcurrent protection of 6, number of lines, number of outlets. So a little bit more detail of the PDU. You'll notice here it's in zone A, and we talked about this in a previous video where when you actually associate the PDU for a rack, during pod view drawer registration, you have 4 zones, A, B, C, and D, that you can place and manage within that particular rack. Because theoretically speaking, you could have a number of particular compute hosts within the rack, and you'll need several PDUs to be able to perform or provide that type of power distribution within the rack. So those would be in zones that you basically have created or you physically mounted inside that rack, and then we associate those various physical locations with basically zones. All right, so let's navigate down. What's unique about this platform is we've grouped these into various groupings, right? And because of the amount of sensor data that's collected, and a lot of the stuff is munged on the screen, and then you have to continually scroll down and things of that nature, we've decided to actually group them and put them into various sections so that it's easy for you to navigate and get the metadata that you need or perform the function you need for that particular PDU. All right, so we've got the PDU overview that we've talked about. So we're going to also skip down to the component mapping on the left-hand side of the submenu. So here we're going to provide you with a very nifty particular outlet mapping and the relationships and dependencies that exist within the outlets. And you can actually click on each one of these and be able to get various different metadata associated with that outlet mapping. So because of the innovation that's going on in the relationships of the PX3, we thought it would be important for you to provide a mapping or relation of child-parent relationships here that exist within the mapping of the PX3 itself. So let's, and so you notice here the L1 is the line 1, line 2, and line 3, and then you have the appropriate outlets to the bank relationships here that we have set up here within our mapping or visualization that we show you for the child and parent relationship. All right, so let's move on to outlet on the side menu here. And the outlet shows you, of course, the mapping or more the list of various particular outlets that are part of this particular PX3. We have 42 outlets, a rather large particular outlet where you plug in your particular devices or appliances to provide power distributed to each of those components that are inside the rack. And then you can see here the various receptacle type, the system power mapping we have set up here, which we actually use and map back to what we've created as our universal agent to support enforcement policy with liquid-cooled data centers, such as performing an enforcement action to shut down the entire rack in the event that there was a leak that was detected here. So we've had to provide you with some sister power mapping to show you that relationship that exists and identify each of those servers that are associated with that rack and or that liquid cooled rack per se. All right. So again, you can click here and then highlight all these, come over into the power management and also perform an on-off type of task. I'm not going to do that because we've talked about this in previous videos of how to do that. So try to keep the video as marginalized or minimized as possible here because I know your time is valuable and we want to try to keep these vignettes as you know, the time duration as low as possible here for you. All right, so individually you can click on here and perform that power management task. You can also issue a edit tag, and that's very useful when you want to associate what server is connected to which particular outlet, right? Maybe perhaps you have a server that you want to be able to track, right? Or you have an application that you want to track associated with that outlet. Maybe it's a EXX hypervisor, or maybe it's a special GPU that's performing a specific LLM model or something like that. And you want to identify that particular outlet of that server to be associated with that. And we do that based on a tagging mechanism and tag management. You can see here over to the left here, we have the line mapping too to show you the relationships here. This is a different view that we show within our table content for outlets. If we go back to the previous component mapping, you see those relationships that exist within the parent-child relationship that we provided or visualized here earlier in this particular video. And then you can look at other things like having to perform a refresh, and then also display here that we have provided to you as well. And we talked about this in earlier videos where you can essentially uncollapse and collapse the table based on the kind of data you're looking for. This particular one here doesn't have a lot of data here to be presented, but if you're going into the compute element list, there's lots of information there. So what we've done is taking that entire methodology or design and basically pulled it across the entire product platform, right, to provide you ease of use and be able to look at data that you're looking for. And then, of course, we can also search on those various different criteria too as well in the element list, right? So if you're having such as a compute list of 25,000 elements in there of hosts that are there, ultimately here it would be very difficult for you to pull the metadata you're looking for to perform that lifecycle management of that server, right? So in this case, by using the search criteria, we can actually minimize or basically filter on a specific server or product SKU or whatever criteria you're looking for to perform that search operation. All right, enough of the outlet. So let's move on to the peripheral devices. The peripheral devices here, as I mentioned before, some of the descriptors are still being developed here. So a lot of this stuff has not been completed here. So we'll skip over that one here and continue on with the inlet information here that is available to you. And so the inlet here is showing you at a high level the inlet type of load or how much typically power we're utilizing in an active power state. And you see the data here that we're actually pulling this real live data. You can see here on the top here, we're scrolling with various different metadata that exist here. And by placing your mouse in the carousel view, the scrolling basically stops, right? So if you're looking for a specific thing that you're trying to determine here, based on management of your PDU controller. You can look at that stuff instead of it scrolling by and saying, wait a minute, what was that information I was trying to look for? So remember that by putting your mouse into that carousel view is going to stop that scrolling. And then simply by removing your mouse in the carousel view, it will continue to scroll. Now it's scrolling at around, I would say, 5-second rate. So it is easily able to see stuff, but sometimes you want to basically say take a screenshot of that or be able to collect the data that you're looking for at that point and be able to perform or mitigate your problem, right? Or you're trying to determine problem resolution of what's going on within the environment, right? By collecting various different metadata, analyzing that data, and trying to determine or solve your problems within your data center. All right, enough of that. We're going to move on to line here. And line is an interesting thing here because it shows some great gauge type of stuff. And I'm really a proponent of gauge type of charting or metered type of metadata or visualization because it really, by looking at it, you can easily see are we in the red zone, the yellow zone, or the green zone, right? And how much particular amperage we're actually pulling here. So I feel it's a great particular visualization tool to help you determine what you're looking for within your data centers, pulling that appropriate metadata. And if we scroll down here, we can also see RMS voltage state and RMS power state. So all the data is there that you're looking for here to be able to perform that necessary lifecycle management for your data center, especially around sustainability and PDU management. All right, we're going to move over to overcurrent protector, and we're going to click on that one. And then we can see other various sensor data we're pulling here based on the C1, the C2. So these are the outlets, or I'm sorry, the banks that we're actually pulling data from, right? So this is very useful information. So we structured this where we're pulling it from each particular hierarchy of the PX3. And remember, all this data is being pulled from that PX3 controller of that PDU. All right, so we're going to move on to outlet. So here we can set up threshold settings here. And those threshold settings can be set here for maximum, minimum, below critical, below warning, and all of these settings you would set. And then based on a situation that would occur, whether you're over subscribing to that particular outlet based on power and that was to trip or whatever, you want to be able to alarm or alert on that and provide that to our webhook architecture to be able to relay that over to an SMTP mail host or potentially to a collaboration tool like Teams, or basically inject that into basically a call tracking system such as ServiceNow or Salesforce, right? So those are going to be very important for you as a data center operator to be able to take that information, set those threshold settings, and then appropriately act on those if those have been met. So that will be very important to provide operationally a sound data center, hardened data center for your environment in your enterprise. All right, so we're going to move on to sensor stuff. Sensor data is really talking about, again, the real sensor information we're providing here. So remember, the threshold setting is what we set. The sensor data is the collection mechanism, which we basically harvest. Let me also mention too as well, and I talked about this in previous videos, some of the PDU manufacturers are still sort of stuck on the SNMP, which relied us to create that universal agent descriptor to be able to provide and pull this information. So of course, we're using the SNMP walk to provide those data elements, right, from the OID, and then basically provide that in a API or RESTful API based on Redfish. So we see some movement here within the PDU manufacturers and other manufacturers starting to move to redfish, and that's very important because then we build in standards, right, for PDU management, and then certainly makes Supermicro's job and my our developer team's job much easier because now we're pulling in the entire metadata from one particular API get call opposed to having to walk the information. And again, we're talking about SNMP as having vulnerability, right? So a lot of this information and metadata is basically passed in what we call clear text on the wire. And so that is a potential for a denial of service attack. And we saw that in what happened in the SolarWinds type of vulnerability that existed there. So hopefully our friends in each of these manufacturers will start adopting basically Redfish and start moving into that API so that it provides good a sound security within your environment, certainly, and then it makes development that much easier. All right, moving on to peripheral devices. That's a mouthful. Peripheral devices. Peripheral devices are probes that sit on the PDU that collect what we call sensor data like temperature and relative humidity. We have other sensor data. Let me mention the Legrand provides quite a bit of peripheral devices for collection. And as we continue to integrate the Legrand PX3 and the various different smart controllers that Legrand is offering, we will start exposing more of those peripheral devices that make sense for your use case within your data center. So there's a lot of peripheral devices out there that are available, and we will continue to actually build on the momentum of full integration with our friends at Legrand, and they've been doing a great job here in innovating their PDU controller. All right, we're going to move on to the analytics piece of this. So in the first grouping, we were talking about sensor reading information. Now we're going to look at the graphs or linear graphs associated with each of the PDU controllers. And we're going to talk about here and related to active power, active energy, RMS current. As you can see here, we have a couple oops messages here that we're still building in our system OID descriptors here that we're pulling here. So you'll see this again in the 3.11 release once it goes out the door at the end of the month. So we're still doing some system validation and still some current development. But you get an idea here based on what we're going to show here. A linear graph or linear chart showing you upper warning, lower critical, and various different charting. And as you can see, you're moving the cursor, I'm sorry, the mouse across cursor. I'm talking the old days, right? Remember we talked about cursors, right? Well, I got to get out of that methodology here because I'm always thinking in my past, right? Of things we're current now, right? We use a mouse, right? So as you move your mouse across here, you can see the delta values and how they've been charted across moments in time of time stamps. So you can see here also active energy. We're kind of going up here a little bit here in our active energy usage. So you can see the charting there. So something was going on here. Maybe we powered servers are up, or we started actually utilizing some GPUs inside this PDU here, and we started seeing some more power consumption here that's being charted across moments in time here. All right, we're going to talk also about line here. And then line, we're showing active power, active energy again, RMS current. We're going to look at overcurrent protector. You can see RMS current, RMS voltage, active power. So you can see the various different charting here. They are color coded, right, for different lines, right? So line 1, line 2, and line 3. You can see here we're pulling various different power across each of these lines. And if you click on here, you'll notice here that when we click on specifically the blue line 1, that line comes to the foreground, and the other two lines, which are line 2 and line 3, go to the background, right? So that easily provides you with a good idea of how you're tracking specifically line 1. All right, we'll look at outlet. So we broken down outlets into active power too as well. You can see here overcurrent protector, RMS current information here too as well. Scrolling down, you see the various different outlets that are provided here and the active energy here of the overcurrent protectors, right? So these are present here for each outlet. And then you have also, of course, the peripheral devices. In this one, we have shown you here the outlet information too as well for each of these outlets. So in the right-hand top here is a date picker. So you can click on here and basically come up with historical trending or historical data that you want to have a look back window of various types of charting that you want for a period of time or delta that you're basically looking for, which is kind of nifty here as well. So that concludes basically all we're going to talk about today on the PX3 controller. As I mentioned, our friends at Legrand are doing great work here of providing you the necessary kind of data or sensor data collection that is important today, right, as it relates to power consumption in the data center. So everybody is super sensitive and super focused on sensor data collection within the data center. And of course, because we have these power hungry, basically GPUs that are requiring lots of power and to be able to cool those GPUs, right? And the whole premise of the evolution of now liquid cooled data centers to cool those particular GPUs is getting more and more important, and a more focus on the power grid and being able to provide sustainability so we're not using too much power on the grid because there's not enough power on the grid to be able to sustain these hungry GPUs. One thing I did not mention here, and we'll quickly do this before we close, is that by scrolling across here, we see various different outlet information here for each of those particular banks. You can see here outlet 28 and the various different delta values that we're tracking across this particular time medium here. So that again concludes everything. Thanks for joining today. I bid you a great day. We'll see you next time.